Hello and welcome back. In my series of light, what is light, I thought I would introduce the photon counting head or photon multiplier tube, and I got my hands on this one, a Hamamatsu H7828, and I mounted it in a box like this, and it's a small module with a window which will accept light and produce a pulsed output depending on how much light is entering the little window here. And I built this this box. I can put a lid on it, and a friend kindly 3D printed a fixture so I can add an LED. And I mean, if I switch on this LED, let's go over and do that like this, the LED will light up like this, quite sharp light. So let's switch that off again. Now, what's a photon multiplier tube? Well, Feynman describes this in his QED lectures, and it's quite straightforward. You have a certain amount of metal plates inside a vacuum tube, and all those metal plates are connected to a high voltage supply. And once a photon strikes the first plate, it bounces off electrons, and those get amplified down the chain. And finally, you can hear a click, or more like you can see a spike on an oscilloscope. So let's try to do that. Before I do it, yeah, well, worth mentioning, the LED supply and the PMT, the photon multiplying tube, are completely separate. So there's no electrical connection between the two. They're galvanized separate. So the only connection between these, the light and the multiplier tube, is by light itself. So if I put on this lid, let's do that. A bit noisy here. Switch off the light here. So. And now I can switch on the photon multiplier tube, and you will see pulses. And you're seeing typically at a second's duration, you'll see 24-20-ish pulses. And this is what we call the dark count of the photon multiplier tube. So occasionally an electron decides to break free and try out life in vacuum, and it gets hurtled down between the different plates inside the tube and gets amplified, and that's what you can see here. So that alone is like a quantum thing. Nobody really knows why they break free, they just tend to do. So just to illustrate how sensitive this tube actually is, I can the LED is off now, of course, so I can just lift the lid a little bit, allowing some light to come in. Let's see if I can do that, like that. And you can see basically it goes nuts. So it's extremely sensitive. It's likely the most sensitive device I have outside radio receivers, actually. So my next plan, let's just switch this off again. My next plan is to insert this LED in its little fixture here, like that. And then run the LED at a very low current, like picoamps. Microamps is way too much, picoamps. And then I'll see if I can see any difference on my scope. I'll probably use another scope with a counter, and statistics, allowing for statistics on my results. And we'll see if I can measure single photons, or at least a very low amount of photons inside this box. So stay tuned for the next video. Cheers.